Hi everyone. In this video we will finish our unit on numeration systems by talking about converting from base 10 to different number bases. So we'll look at 5 different examples, and this is similar to what we did in the beginning when we first talked about grouping by different numbers, such as grouping by 3s or grouping by 5s. But what I'd like to do is some longer examples and give you 2 different methods to be able to handle any size number. So for example 1, let's look at 48. And let's write this in base 3. Right now this is a base 10 number. We know that because there's no subscript. Okay, we could write 48 with a little 10, but if you don't see a subscript, then we assume that it is base 10. Okay, so to write this in base 3, option 1 is to think about the different place values in base 3. Everything groups by 3s. So we have the 1's place, then the 3's place, then the 9's place, which is 3 squared. Right, then 3 cubed, which is 27. 3 to the 4th, which is 81, and so forth. Now I know that this number won't need the 3 to the 4th place because it's only 48. We don't have even one group of 81. So this tells me that this is going to be a 4-digit number. And so to begin with, I'll start with the largest place value and look at the 3 cubed place and try to decide how many groups of 27 are in 48. So one way to do this is using a calculator. 48 divided by 27 and see what that equals. And you should get 1 point something. Okay, there's some decimal places after that, but the whole number, the 1, is the part that tells us that there's one group of 27 in 48. Alright, so that first digit is going to be a 1. Now, I need to know how much is left over to go in these other 3 places. Alright, so the next step is to subtract 48 minus one group of 27. And if this digit had been like a 2 or a 6 or something, okay, well, couldn't do a 6 in base 3, but if that had been maybe like a 2, then I would have subtracted 2 groups of 27. Okay, and then 48 minus 27 is 21. So then I move on to the next place value, the 3 squared place, right, the 9's, and we see how many 9's are in the remaining amount of things, the remaining quantity, this 21. Alright, so again you can use a calculator if needed, if the numbers are large enough, and 21 divided by 9 should tell you how many groups of 9 there are. And this is 2 point something and it continues on. So 2 groups of 9. So the next step again after division is subtraction. So start with 21 and take away 2 groups of 9 and see what's left. Alright, well that's 21 minus 18, which is 3. So that leaves us with enough for one group of 3, and then 3 minus 3 is 0, so we don't have any left to go in the 1's place, so 0 1's. Alright, so 48 in base 3 could be written 1, 2, 1, 0, and then with a little subscript to show that this is base 3. Alright, so let's summarize here. This representation, what this is really saying is that 48 is one group of 27 plus 2 groups of 9 plus one group of 3 and 0 groups of 1. So if you work this all out using order of operations, multiply and then add, all right, double check and make sure that that does equal 48, and if so, then you know that the answer is correct. Alright, so that's one way to do this. Let's look at a second method. This is a nice shortcut. I don't think it's quite as obvious why we're using this method, but it does go a little bit quicker, especially if you don't feel like figuring out ahead of time what all of those different place values are. So in the shortcut method, you start with 48 and we're going to do a series of long divisions. So I'll start at the bottom here. And we're going to divide by whatever the base is, in this case a 3. Alright, so 3 goes into 48, and use a calculator if needed, but that's 16. And then next to it you write the remainder. Alright, so this is a remainder 0, it divides evenly. Okay, then 3 goes into 16 5 times, and then a remainder. Now, you will have a decimal remainder on the calculator if you're using that, but we're not interested in the decimal, we're interested in the whole number remainder. So to find that, right, figure out what 3 times 5 is, right, 15, subtract that, and that's your remainder. Okay, continuing on, we'll divide again. Divide 5 by 3, so 3 goes into 5 one time. And once the remainders get, small enough, you can probably work these out in your head. So 3 goes into 5 one time, remainder 2. But again, to find that, you would be doing 5 minus 1 times 3. Okay, and then we're not done yet. As long as you still have a number here, you keep going. So we're going to divide again. 3 goes into 1 0 times, which means that entire 1 is left over as a remainder. And now we stop. You stop whenever you see a 0 at the top of this series of long division problems, and that tells you that you've used up all of these 48 things, whatever we were counting, and grouped them by 3's. Now, to figure out the answer, you just read the remainders straight down, 1, 2, 1, 0. All right. So basically what we've done here is, with this first division by 3, we've taken all 48 things and split them into 3 piles of 16. And then we've just kept going, and every time we group by 3's again, right, we're just interested in seeing, do we have 3 of anything? Do we have 3 3's? Do we have 3 9's? Do we have 3 27's, etc.? So this is similar to our base 10 system, where we divide everything into groups of 10, but then we don't stop there. We look to see if there are 10 groups of 10, if we can make any hundreds, and then if we had 10 hundreds, we see if there are any groups of 1,000, and so forth. Okay, let's try a second example. Write 51 in base 2. So using the first method, I would write out the powers of 2 and think about the largest power of 2 that is smaller than 51. So I have 1's, 2's, the 4's place, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. That's larger than 51, so we stop there, and this is going to be a 6-digit number. Alright, so how many groups of 32 go into 51? Alright, one group of 32. So 51 minus 32 leaves 19 left over to be distributed among all of the other places. How many 16s are in 19? One group, so 19 minus 16 is 3. Okay, now we're working with 3, so we don't have enough to make any groups of 8 or any groups of 4, but we do have enough to make one group of 2, and then subtracting 3 minus that one group of 2 leaves 1 left over, which is enough to make 1, 1. So the answer here would be 1, 1, 0, 0, 1, 1, and then a little subscript 2 to show that it's base 2. Alright, let's try the second method. So we'll start with 51, and since this is base 2, we're going to repeatedly divide by 2. So 51 divided by 2 is 25, and then there's a decimal portion to this. To find the whole number remainder, do 2 times 25, that's 50, and subtract from 51. Okay, so remainder 1. And then divide again. Okay, 2 goes into 25 12 times. Again, a remainder of 1. Okay, so I would be doing 25 minus 2 times 12, minus 24. And then again, 2 goes into 12 6 times. That goes evenly, so there's no remainder. 2 goes into 6 3 times, again with no remainder. 2 goes into 3 once, but there's 1 left over. Okay, that's 3 minus 2 times 1. And then 2 goes into 1 0 times, so that 1 is left over as a remainder. So again, reading down, here's your answer, 110011 base 2. All right, a third example. Write 258 in base 6. So using the first method, right, base 6, we have 1s, 6s, 6 squared is 36, 6 cubed is 216, and 6 to the 4th is 1296, and that's higher than 258, so we'll stop there, and this is going to be a 4-digit number. All right, so how many groups of 216 are in 258? That's one group. And then subtract 258 minus 216 is 48. How many groups of 36 are in 48? That's one group, so 48 minus 36 is 12. Oh, I'm sorry. I have a subtraction error here. Let me back up. This is a 42. Okay. So still enough to make one group of 36, and then subtracting leaves 6. Okay, so that's enough to make one group of 6. 6 minus 6 is 0, so that leaves 0 left over for the ones place. Now it's important to put that 0 even though it is in the last place, just as in base 10. There's definitely a difference between, say 100 versus 10 or something like that. Alright, so the final answer is 1110, a subscript 6 to show that it's base 6. And then let's look at method 2. Okay, start with 258 and divide by 6. And that's 43, remainder 0. Okay, 6 goes into 43 7 times. And then 6 times 7 is 42. So subtracting, that leaves a remainder of 1. 6 goes into 7 one time with 1 left over. And then 6 goes into 1 0 times with that 1 left over. And you should see the same answer, 1110 base 6. Okay, example 4. Write 84 in base 9. So option 1, we've got the 1's place, the 9's place, the 9 squareds or 81 place, and then 9 cubed is going to be 729, and that's bigger than 84. So we have one group of 81 in 84. Okay, that leaves 3 left over. And that's not enough to make any groups of 9. Okay, and so then that 3 is enough to make 3 groups of 1. Alright, so 84 in base 9 is 103 base 9. Method 2, the shortcut division method. Start with 84 and divide by 9. So 9 goes into 84 9 times, and there's a remainder of 3 because that's 84 minus 9 times 9, or 81. Okay, then 9 goes into 9 exactly 1 time with no remainder, and then 9 goes into 1 0 times, remainder 1. And there you see the same answer. And one last example, example 5. Write 122 in base 8. So we have the 1's place, the 8's place, the 8 squared or 64's place, and then 8 cubed is 512. Okay, so that's too big. So how many groups of 64 are in 122? Right, one group. So 122 minus 64 is 58. Then how many groups of 8 are in 58? Okay, so again, using a calculator, you could do 58 divided by 8 to figure this out, and that's going to be 7 point some sort of a decimal remainder, so there are 7 groups of 8 in there. And then 58 minus 7 groups of 8, which is 56, gives 2 left over, and that's enough to make 2 ones. So this should be written 172 base 8. And then we'we'll check using the other method. 122 divided by 8 is 15. Okay, that's a remainder of 2, since 122 minus 8 times 15 is 120, gives a remainder of 2. 8 goes into 15 once, with 7 left over, and 8 goes into 1 0 times, and that 1 is the remainder. So 172 base 8. Okay, so that's the last example that I will work together for you. Now, I did want to point out just a couple tips for making sure you're on the right track. Some common mistakes. Don't forget to stop only when you see a 0 at the top of this long division method. A lot of people stop too soon, possibly when you see a 1 up there. Another tip is that all of your remainders represent digits in the number, so you should only be seeing digits that are less than whatever base you're working in. So just like in base 10 numbers, we don't have, a digit of 10 or 11. We only stop with 9. We use digits 0 through 9. Anytime we have 10 of something, we can regroup and make 1 of the next larger group. So just like that in base 8, I would never have like an 8 here. If I have 8 of something, that's enough to bump it up to the next place value. And then finally, we keep asking that question, how many groups of 8 go into this, or how many groups of 64, etc. And you always choose the maximum number possible. All right. So if I went back and looked at the first method on this, okay, and let's see, we had 8 squared, which is 64, and then 8, and then 1. All right. So if I had done, let's see, one group of 64 and subtracted that to get 58, and instead of doing 7 groups of 8, let's say I'd only done maybe 6. Okay, so that's 48. Then when you do 58 minus 6 times 8, which is 48, that gives you 10 left over, and that looks a little funny to have 10 ones. All right, so you should be able to catch it when you move on to the next place value, but just in case this sort of error pops up, here's the reason why. It's because you didn't choose the largest number of groups possible for any one place value. Okay, that ends my comments on this section. I hope this was helpful. So at this point, you should be able to convert back and forth between base 10 and other bases, and also understand how to count in different bases, and be able to represent the same number in a variety of different ways. Okay, thank you for watching.